A couple of things I want to discuss with you guys. Number one, we're going over section 3.5 today, which is the last section before your test, which means that you guys got some stuff to do. Number one, and you got your, and I scroll down here, you'll see, since it's time for our next test, I have your Math 1120 homework number 2, test review number 2 ready for you guys for chapter 3. So here's a direct link to it. You can print it out and copy it, but I actually made you guys a copy of this thing. So I will be passing this out in the class just to save you some paper there. But what I do want you to do, just like last time, is you're going to turn this thing in on Monday. That's when it's due, Monday, February 25th, at the beginning of class. And I'm going to go over this thing with you guys, okay? But you have to turn it at the beginning of class. So I want you to make another copy of this guy to have a blank copy so we can work along in class on Monday, because you're going to turn in this thing, obviously, for a grade. And right now, I'm passing back your homework number 1, so it's making its rounds, and they're supposedly alphabetical and stuff like that. So good luck with that, and grabbing your paper out of that set. So, you know, with homework sets, since I actually do them in class, you know, I let my grader have a few extra days on trying to get that stuff done. I'm real adamant about trying to get the test back to you guys as quick as possible. But since I actually go over the homework set and record it for you guys, you know, it took a little while, but we got your homework sets back, and now here it is again, your next homework number 2 is due. And it is due on Monday, which also means what? Wednesday is your test number 2. Also, when you go over to your Hawk system, you've got quiz number 5. That is going to be due on Saturday. That's on that section 3.2 and 3.4 stuff there. We also have your, by Sunday, you got to be done with your homework from the lessons of 3.4a and 3.4b. And of course, we have our in-class test, and actually your homework number 2 is actually due next week. So lots of things going on here, just to pay attention to it. So there you go. All right. So let's pick up where we left off last time, because we've got a few more problems to do, but it's going to lead into what we're going to be talking about in section 3.5, which is absolute maximums and minimums. Right now, we're finding local maximum minimums. We're trying to figure out where the biggest point and the smallest point on the problem is at. So let's take a look at where we left off last time. We just got started on it, but I didn't get a chance to actually finish it up, and that is this problem right here. F of x was equal to negative 2 times 3x squared minus 12 squared plus 9. Directions say find all relative extrema. Find all maximums and minimums, local maximum, local minimums, okay? And so find local extrema. So first thing we're going to do is we took our derivative. And this one I used a chain rule. The 2 popped out front, multiplied times the negative 6, made it negative 12. Inside stayed the same, 3x squared minus 12 to the first power. And then times, chain rule, times derivative of the inside derivative of 3x squared is 6x, derivative of minus 12 is 0. Plus the derivative of 9 is 0, so that went away. So I cleaned them up, and then I set it equal to 0. And since it was already factored, I set each factor that has an x in it equal to 0. The negative 12 doesn't have an x in it, so you just ignore that one. So I set the 3x squared minus 12 equals 0, and the 6x equals 0. Well, I divided by 6 on both sides and got x equals 0. Here I added 12, so I got 3x squared equals 12. I divided by 3 and got x squared equals 4. But when you have to introduce a square root in a problem, don't forget plus or minus. So the square root of 4 plus or minus is going to be plus or minus 2. So you actually end up getting 3 what we call critical numbers, okay? Critical values. 0, plus, and minus 2. So I put them on my number line in order, negative 2, 0, and 2. And now I'm going to do test values. So here's my derivative right here. I'm going to pick a number less than negative 2. So I'm doing the same thing as what I did before, finding intervals of increase and decrease, but that's going to tell me who my maximums and who my minimums are. So pick a number less than negative 2. I choose negative 3. And I'm going to plug it into my derivative. And I'm going to show you guys a little trick on the old calculator here to save you guys some time. So I'm going to plug in negative 3 into this equation, my derivative equation. That is negative 12 times parentheses 3 times negative 3 squared minus 12, close parentheses there, times 6 times negative 3. And I put parentheses around it, but every time there was an x in my derivative, I plugged in a negative 3. And I hit enter, and it gives me a whopping 3,240. I don't care what the number is, it's positive. So everybody in that interval is positive. Now I'm going to pick a number between negative 2 and 0. I choose, obviously, negative 1. I'm going to plug negative 1 in there. But here's the trick. On the calculator, there's something called an entry button. It's in blue, so it's second entry. But the second entry, when you hit that button, it calls back down the last thing that you did, and it's in edit mode. So, because all I'm going to do is change all those negative 3's that I plugged in to negative 1's. Saves a lot of time, and I get negative 648. It's negative, so everybody in that interval is negative. I'm going to pick a number between 0 and 2. Obviously, I picked 1. I'm going to plug in 1 into this derivative. So I'm going to go second entry. It calls it back down. And all I'm going to do now is just get rid of those negative 1's and make them positive 1's. So delete the negative on the 1's. And I get a positive 648, but it's positive. And then I pick a number bigger than 2. I choose 3. And now I'm going to change all those 1's to 3's and plugging into my derivative. Again, it saves you lots of time when using the calculator there because we're doing test values. Plugging in 3 for the x, plugging in 3, and I end up getting a negative 3,240, and it's negative. Now, here's the big deal about what we were discussing last time. We're looking for, quote, local maximums and local minimums. You analyze the number line, the analysis line, as the folks like to call it, our number line, a derivative number line. This, from negative infinity to negative 2, my function is increasing. From negative 2 to 0, my function is decreasing. What does that make negative 2 when you go up and then go back down again? This is a maximum. And then I go down and hit 0, go back up again. This is a minimum. I go up and go back down again, and 2 is a maximum. So, but we want what we call critical points. We like to describe these max and mins as an ordered pair. So my points are negative 2, 0, and 2. Okay? But I need a y coordinate. What do I got to do to get a y coordinate of a particular function? I take my x and plug it where? Not into the derivative, but back into the original equation. So here we go again. Taking my calculator, I'm going to type in negative 2 into the original equation. It'll be negative 6 times parentheses 3 times negative 2 is what we're plugging in. We're squaring it. Minus 12, close parentheses squared, plus 9. And then I'm getting 9 itself. Now I'm going to plug in 0 for my x. 0 to 2 there. And I end up getting negative 855. And when I plug in positive 2 into my function, I get 9 again. So let me go analyze these points. At negative 2, it was a maximum. So we would say it's a local max. At 0, it was a minimum. So we would say it's a local minimum. And back at 2 again, we're back to being a maximum. So at 2, it is a local maximum. And just one more thing I want to talk to you guys about with this stuff is this. So when we analyze these guys, we sit there and talk about, it occurs at is the x-coordinate, the value is the y-coordinate. So what is the maximum value of this particular function? Well, when x is negative 2, occurring at negative 2, the value is 9. And even at positive 2, the value is 9. And the local minimum, it occurred at x equals 0, and the value was negative 855. So we're kind of sparsing our points to actually answer word problems. So let's take a look at this next guy. Same directions. It says, quote, find out critical values and use the first derivative test to find any local extrema. Okay? So first thing I'm going to do is take my derivative. Derivative of 2x cubed is 6x squared plus the derivative of 3x squared is 6x minus derivative of 72x is 72. Derivative of 5 is 0. I'm going to take my derivative and set it equal to 0 and solve. But you'll notice that I have a 6 in common for each one of these guys. So I'm going to factor out that 6. That leaves me with x squared plus x minus 12 equal to 0. And this is going to factor very nicely. Let's see, x and x. What times what is 12? That differs by 1, 4, and 3. Since it's a minus, opposite signs, middle terms plus, plus on the 4, minus on the 3 equals 0. You set each factor equal to 0 and solve. And I get x equals negative 4, and I get x equals 3. These are my two critical values. So my critical numbers, I'm going to put on my number line here. They are in order, negative 4 and 3. And now this is my derivative number line. So I'm going to plug into my derivative. I'm going to pick a number less than negative 4. I choose negative 5. And I'm going to plug it into my derivative. My derivative was 6 times negative 5, and for x squared, plus 6 times x, which is negative 5, minus 72, and I get 48. I don't care what the number is, it's positive, so everybody in that interval is increasing. Pick a number, use your brain. Between negative 4 and 3, I choose 0, because I don't need much work to plug in 0. For that guy, I get negative 72. It's negative. And now I'm going to pick a number bigger than 3. I choose 4, and plugging 4 in for my x's on my derivative. That becomes 6 times 4 squared. Place the negative 5 to 4 squared plus 6 times 4 minus 72. I get 48 again. It's positive. So I'm going to identify my critical values here. And I got 2 points, negative 4, and I get 3, and I get to figure out the y coordinates. But here, analyzing, this is called the first derivative test. I'm increasing and then I'm decreasing. What does that make negative 4? That's going to be my local maximum. And I'm going down, I get 3 and come back up. That makes 3 a local minimum. Now to actually get the values, the maximum, the local maximum value and the local minimum value, I'm going to take my critical numbers, negative 4 and 3, and plug them back into the original function. So plugging in negative 4, 2 times negative 4 cubed plus 3 times, oops, error there, plus 3 times negative 4 squared minus 72 times negative 4 plus 5. And just double check yourself to make sure you didn't screw something up in typing it in. Yep, plus, plus, plus. And I end up getting 213. And now when I plug in 3, I call it back down just to save myself lots of time. I plug in 3, and for all the x's into the original function. I end up getting negative 130, which means my local maximum is at the point negative 4, 213. The maximum value is 213. It occurred at negative 4. And the local minimum point is positive 3, negative 130. It occurred at x equals negative 3, and the local minimum value is negative 130. Well, take a look at these problems. Just like we did before, when you start looking at functions that now have division in them, clearly to be able to take derivative, I'm going to have to use the quotient rule, but I got a problem with this guy. And so when I have a problem, I got to identify the problem right from the get-go. In this problem, f of x is equal to 2x squared, 25x squared plus 4 divided by x, you can clearly see we have a domain issue. The domain issue is x cannot be equal to 0. So I'm going to have to automatically omit 0 from any number line because it doesn't exist in the problem. But then I still got to find my critical numbers. To find the critical numbers, you take derivative, set equals 0, and solve, and you got to pay attention where the derivative doesn't exist at. So let's take our derivative. 25x squared plus 4 divided by x means I can use the quotient rule. Quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom, all over the bottom squared. So they get a little nasty here. So derivative of the top, derivative of 25x squared is 50x, derivative plus 4 is 0. Derivative of the top times the bottom minus the top, 25x squared plus 4 times derivative of the bottom, the derivative of x is 1, all over the bottom, x squared. Now I'm going to clean it up. This is equal to 50 times x is 50x squared minus, now times 1 pretty much is the same thing, but that negative is going to distribute and change my signs. That'll be minus 25x squared minus 4 all over x squared. And one last, 50x squared minus 25x squared is 25x squared minus 4 over x squared. This is my derivative. The prime of x is equal to 25x squared minus 4 over x squared. To find critical numbers, you've got to take derivative, set it equal to 0, and solve. So I'm going to take this guy equal to 0. Now I notice also where the derivative doesn't exist at is at 0. But 0 doesn't exist on the problem as well, so I'm going to have to omit 0 anyway. So I'm going to set this guy equal to 0, and I'm going to solve for x. When I have a fraction equal to 0, my first move is to multiply both sides by the common denominator. Get rid of your fractions. And when I multiply both sides by x squared, this cancels on over on the left side, and I get 25x squared minus 4 equals 0 times x squared is 0. I'm going to solve for x squared here, so I'm going to add 4. So I get 25x squared equals 4, and then I'm going to divide by 25 on both sides. That gives me x squared is equal to 4 over 25. Yay for you guys, fractions. But now, what kills off the square? And you have to introduce the square root into the problem, so don't forget to do what? Plus or minus. So you take square root of both sides, and only even radicals get plus or minus. If it was the cube root, you only just take the cube root, and it's going to be a positive cube root. But with square roots or even roots, you have to actually take plus or minus. So this cancels, and I'm left with x is equal to plus or minus. Well, the square root of 4 is 2, and the square root of 25 is 5. So I end up getting two critical numbers. So I'm going to draw my number line. I'm going to put my two critical numbers on there, negative 2/5 and positive 2/5. However, I also have to omit 0 because that's not even defined in the function, nor is it defined with your derivative. So it subdivides this particular number line into 4 sections. Now we're playing fractions here, so here we go. Pick a number that is less than negative 2/5. I choose negative 1. And I'm going to plug negative 1 into my derivative function. Parentheses around your numerator. 25 times parentheses, negative 1 squared minus 4, close parentheses, divided by parentheses, negative 1 squared. And I end up getting 21. I don't care what the number is. The fact is, it's positive. Now, here comes the more interesting one. I got to pick a number between negative 2/5 and 0. What number you suggest? I suggest negative 1/5. That will be between negative 2/5 and 0. Okay? If you think about this, negative 2/5 is the same thing as negative 0.4, so you basically plug in negative 0.2 or something like that if you want to go decimals on this thing. So I'm going to sit there and recall this guy down, and I'm going to go back and insert for x's a negative 1/5, so I'm inserting the divide by 5 on my x part here. And I end up getting negative 75. I don't care what the number is. The fact is that it's negative. Similarly, I'm going to plug in a number between 0 and positive 2/5. I choose a 1/5. So recall this guy back down. And notice something happens. When I delete the negatives, make it positive, but because we're squaring all this stuff, I end up getting the exact same answer. Negative 75, it's negative. It didn't change signs. This is when you have to do the test values because you're not sure what the signs are going to be. And then pick a number bigger than 2/5. I choose 1. F prime of 1 would be, recall this guy back down, and replace the 1/5 with just 1. So delete all those divided by 5 things again. And I end up getting 21 again, which is back to being positive. Remember, 0 is actually not a critical point. It's a point that doesn't exist. So I'm going to ignore this guy. He doesn't really count. But look at your critical number of negative 2/5. You go up, and then you go back down again. That makes the negative 2/5 the maximum point. I go down, and then I hit my critical number, and I go back up again. That makes positive 2/5 the minimum. So as I talk about points, this is negative 2/5 and positive 2/5, and the negative 2/5 is going to be my local max, and the positive 2/5 is my local minimum. And now all I need is the actual y coordinates to see what point it is. So what am I going to do? Take these x coordinates and go back and plug them into the original equation. So here we go, parentheses around your numerator. 25 times, parentheses, negative 2/5 squared plus 4, close parentheses around your numerator, divided by parentheses around your denominator, negative 2/5. So notice how I'm typing it in, because we were just talking about before class, it's real easy to make careless errors with this stuff. You put one parenthesis in the wrong spot, makes the whole thing wrong. Let's see what I get. I got negative 20. And now I'm going to change that negative 2/5 and plug in my other point, which is positive 2/5. That makes it a little bit easier. All I got to do is get rid of the negative. So I call it back down again on the calculator, put in the positive 2/5 for my x's, and I end up getting positive 20. So to answer the question, the local minimum is 2/5, and the minimum value is 20, and the local maximum is occurs at negative 2/5, and the local maximum point is at negative 20. Okay, and one more, and then we'll move on to our last section here. F of x is equal to x squared minus 1 divided by x. Once again, this is a quotient, and I notice in the denominator, if x is equal to 0, this function doesn't exist. So I have a domain issue. X cannot be equal to 0. So now, I'm going to take my derivative, once again. F prime of x is equal to, this will be the quotient rule. Through the top, 2x, derivative minus 1 is 0. Through the top times the bottom x minus the top, x squared minus 1, times through the bottom, which is 1. Don't forget to use your parentheses on this stuff. All over the bottom, x squared. Through the top times the bottom minus the top times through the bottom, all over the bottom squared. Clean it up. So this becomes 2x times x is 2x squared. X squared minus 1 times 1 is still x squared minus 1, but that minus with the parentheses in front will distribute and change your signs. It's minus x squared plus 1 over x squared. So I'm left with f prime of x is equal to 2x squared minus x squared is just x squared plus 1 over x squared. Now I'm going to find my critical numbers by set it equal to 0 and solve. Find these critical values. You take derivative, set it equal to 0 and solve. Now on my number line, I automatically got one number, 0. Can't exist. Now I'm going to solve this guy, but just like we did in the last problem, when I have a fraction equal to 0, I'm going to multiply both sides by my common denominator. So multiply both sides by x squared. This cancels, so I'm left with x squared plus 1 is equal to 0 times x squared is 0. Now solve for x. Well, I'm going to get the x squared by himself, so x squared is equal to, subtract 1 from both sides, it's negative 1. Now what kills off a square? Square root. What is the square root of negative 1? Can't do it. Does not exist. You can only take the square roots of positive numbers, or 0, but you can't take the square root of a negative number. So in other words, does not exist, that x is equal to no critical numbers. There are no critical numbers, so there's no other numbers I need to put on my number line. But we did have to put 0 on there because 0 didn't exist on the original function. That was a domain issue, so you've got to admit that guy from the get-go. So now I'm still going to do my test values on this thing to see what's going on here. So I plug in a number less than 0. I choose negative 1. I plug in negative 1 into my derivative. This would be negative 1 squared plus 1 over negative 1 squared. Negative 1 squared is 1 plus 1 is 2. Negative 1 squared is 1. 2 divided by 1 is 2. So it's positive. So in this interval, it is increasing. Now 0 doesn't exist. That's a vertical asymptote. But over here, I'm going to plug in a different value, positive 1. And I end up getting 1 squared plus 1 over 1 squared, which is 1 squared is 1 plus 1 is 2. 1 squared is 1. I get 2 again. It's still positive. So this function is increasing. It's increasing from negative infinity to 0, union 0 to infinity. There are no critical points. Does that make sense? And so, yes, there are problems out there that you don't have maximums or minimums. Now, the difference between what we were doing in section 3.4b and 3.5 is subtle, but it's one big thing. So let me give you the gist of this. And that is this. We're going to be talking about, we're switching one word, and that word is an absolute maximum or minimum. So what they're going to do is they're going to give you a function. Okay? They're going to give you kind of functions, but they're going to define it over a particular interval, closed interval, from A to B. And this is going to be a continuous function. And what I mean by continuous function is we're going back to the old school. I'm not going to lift my pencil from the paper between A and B. Now here's the deal. If I draw this situation out here, and it maybe look like something like this. This is my function. Here's the old y-axis. Here's the x-axis. You know, in terms of this function f of x here, I'm going to talk about this point. A is right here, and B is located right here. So I don't care about the rest of the graph. I'm only looking between these 2 points. And according to our theorems here, that between any 2 points where we have a continuous function, we are guaranteed there's going to be an absolute maximum being the biggest point in the entire graph, and there's going to be an absolute minimum. In this particular graph, where is the absolute minimum at? Where's the smallest point? It's down here. And what point is that? I'm going to call him x1, but this x prime of x1 is equal to 0. This is the critical point. That's where you get your horizontal tangent line. This is where you get the derivative is equal to 0 at. But where is the maximum at? So here is, like I said, the minimum. Where's my maximum point at on the between A and B? Where's it at? It's actually right here. The maximum point is not a critical point. It is actually what we call an endpoint. So, for absolute maximums and minimums, they're either going to occur at a critical number inside your interval, or it's going to occur at the endpoints. So what we're going to do is to figure out who's who, we're going to get critical points, and we're going to compare endpoints. Now let me describe to you, what is a point? It's an x and y coordinate. So very simply, how do I figure out who the absolute max is going to be? It's the point with the biggest y coordinate. How do I figure out who's the absolute minimum point going to be? It's the point with the smallest y coordinate. So we're going to do a comparison between endpoints and critical points. That's what this section's all about. So that's the gist of it. Now to discuss in terms of the words and the concepts of the learn mode here. If C is the domain of a function, and for all x inside the domain, we have f of x is equal to, f of x is less than or equal to f of c for the entire function. If f of c is the biggest y coordinate around, then f of c is called the absolute maximum value of f of x. And B, if f of x is greater than or equal to f of c is the guy on the bottom for the entire graph, then f of c is called the absolute minimum of f. But here's the deal. If a function f is continuous, you've got to have a continuous function, on a closed interval between a and b, then f will have, you are guaranteed, an absolute maximum value and an absolute minimum value. If I've got a closed interval, I can have an absolute maximum and minimum value. If you look at this particular one, if I don't have a closed interval, if I talk about classic parabola, look at your parabola. What kind of points do you have in terms of critical points? There's only one. It's down here. You have an absolute minimum. There is no absolute maximum. because I'm defining it for all real numbers for the entire domain. But once I start cutting it off and looking at regions, then I'm gonna have an absolute maximum minimum. So, and that's what we're saying here. If you got a continuous function over a closed interval, you will always have an absolute maximum and an absolute minimum. Part 3 says this. To find the absolute extremum of continuous function on f on the closed interval, this is your steps. Step 1A. Find all critical values. We're going to take derivative, set equals 0 and solve. Critical values for f in a and b. You got to make sure they're inside your interval a and b, because they're outside your interval, we don't care about them. We only focus on between a and b. Evaluate, okay, this f of a, your endpoint, f of b, the other endpoint, and f of c, the critical values. You're going to have to get the points, the y coordinates on these guys. And here's the deal. The largest value I found in the previous step is the absolute maximum point, and the smallest value found is going to be the absolute minimum. You're going to compare y coordinates, and that's how you're going to identify who the max point is and who's the min point going to be. Absolute max, absolute min. So, take a look at the next page. Again, for our video example, coming from the famous HawksTV.com, they do a problem very similar to this, but I want to make sure we do a problem like this in class. And you notice that it's a classic word problem here. It says this: the weekly revenue from the production of sale of X units of oil is given by R of X equals 78X minus 3X squared, $1,000. And cost is given by C of X equals X squared plus 30X plus 7 in thousands of dollars. Find the number of units of oil that are to be produced to maximize. All they care about is to maximize profit between 0 is less or equal to X, which is less or equal to 27. So first thing, they want me to do what? Maximize who? Profit. I got to come up with a profit equation. But luckily, we've all studied this. Profit, we call it big P of X, is equal to revenue minus cost. So this would be, my revenue function is 78X minus 3X squared, minus my cost function is X squared plus 30X plus 7. Let's clean that up. So my profit equation is going to be 78X minus 3X squared. This negative is going to distribute, make it minus X squared minus 30X minus 7. So my profit equation is going to be 78X minus 30X. What do I got? 78 minus 30 is 48X minus, what is minus 3X squared minus X squared? How many X squared do I got? Minus 4X squared minus 7. So combining like terms is what I'm doing. So that becomes my profit equation. But we want to maximize and minimize. Or in this case, all we really care about is the maximum. Minimizing profit is kind of lame. But maximizing profit is really what we're after here, right? Okay, only the government gets away with minimizing profit. So P of X equals 48X minus 4X squared minus 7. How do I find maximum minimums? First thing I'm going to do is take my derivative, set equals 0, and solve. Let's find that critical number. So my derivative of 48X is 48. Minus derivative of 4X squared is 8X, and derivative minus 7 is 0. I'm going to set it equal to 0, and I'm going to solve. So I'm going to add 8X to both sides, so 48 equals 8X divided by 8. And I end up getting X is equal to 48 divided by 8, which is 6. This is my critical number. And you'll notice that it is, and this is my little symbol, and double check it, it is inside the interval between 0 and 27. They gave me between 0 and 27 because that's what I can focus on. Because if it wasn't, I would throw them out. I only use critical numbers that are between my endpoints. Now, here's my comparison. We're going to go for a CP, critical point, and we're going to compare it to the EPs. This is my code. CP, critical point. EP, endpoints. My critical point, the critical number was 6. I need the y coordinate. My endpoints are between 0 and 27. You always have two endpoints here. So now I'm going to grab my handy dandy calculator here. And I'm going to plug these numbers back into the profit equation. And remember my profit equation, I cleaned them up. It's 48x minus 4x squared minus 7. So plugging in 6, 48 times 6 minus 4 times 6 squared minus 7, I get $137. 137. We'll talk about units in a second. When I plug in 0, I don't need any help with that. When I plug in 0, I get -7. And when I plug in 27, let's see what happens when I plug in 27. So insert 27 and delete the 6 there, and insert a 27 and delete the 6. I get a whopping -1627. Now, here's the deal. You got your critical points comparing to your EP, your endpoints. Look at the y-coordinates. The one with the biggest y-coordinate is the absolute maximum. Which one has the biggest y-coordinate? The 6, 137. This is your absolute maximum. Which one has the smallest y-coordinate? -1627. This guy is your absolute minimum. So, and understand what's going on here. When I sell 6 units of oil, I will make in profit $137,000. Remember, these dollar amounts were in thousands of dollars. If I sold no units of oil, I would end up losing minus $7,000. And amazing enough, if I sold 27 units of oil, I would end up losing $1,627,000. That's actually $1,627,000. So don't sell that. Okay. So to maximize profit, what is our ultimate goal here? Is this. And remember, here we go. Word problem. Make sure. Number one rule of word problem is answer the question. What's the question? Find the number of units of oil to be sold. What's the number of units to maximize profit? X equals 6 units of oil. That's the actual answer. Does that make sense? So, getting into this maximizing, minimizing stuff here. Here we go. Find the absolute extrema for each of the function on the given interval. F of x is equal to -5x plus 5 on the interval between -3 and 9. Well, this one's a trivial problem, so you're going to see this. So f prime of x. First thing you do is you're going to take your derivative. Derivative of -5x plus 5 is -5. Now on the interval between -3 and 9. But I got to find my critical numbers, my critical values. How do I find critical values? I take the derivative, -5. I set it equals 0 and solve. But there is nothing to solve for. There are no critical points because there's no x. Does that make sense? So, if it's going to have a maximum minimum, it's got to occur at the endpoints. Since we have no critical points, we're going to compare it to the EPs, endpoints, -3 and 9. So I'm going to plug in -3 into my original equation. -5 times -3 is 15 plus 5 is 20. And I'm going to plug in 9. -5 times 9 is -45 plus 5 is -40. Which one has the biggest y-coordinate? The 20 does, so this is going to be the absolute maximum point. Which one has the smallest y-coordinate? This guy is going to be the absolute minimum point. You are guaranteed to have a absolute maximum on this stuff. There were no critical points on this one. However, the next one, there is. F of x equals 9x squared plus 18x. Sandus, could you come up here for a second? F of x equals 9x squared plus 18x minus 4 on the interval between -3 and 2. Pass one of these out. All right. First thing I'm going to do is find a critical point. You got to go for the calculus. Take derivative. Derivative of 9x squared is 18x plus derivative of 18x is 18. Set it equals 0 and solve. 18x, subtract 18 from both sides, equals -18, divided by 18 on both sides. X is equal to -1. But check, is -1 inside your interval between -2 and -3 and 2? Yes, it is. If it's not, get rid of it. And now we're going to compare. Critical point, the critical point was -1 compared to the EPs, the endpoints. The endpoints are -3 and 2. And we're going to look at the y coordinates. So grab my handy dandy calculator and plug in these numbers. 9 times -1 squared plus 18 times -1 minus 4. I get -13. Plug in -3. So I'm going to recall it back down and replace all those -1s with -3s. And I get 23. And now I'm going to plug in 2 into my function there, my other endpoint. Plug in 2 and get rid of the 3 there. And I end up getting 68. Okay? So, as we compare, and I just showed you, while to get to the y coordinates, I plug these x coordinates into my original function. Now, who's the biggest y coordinate? 68. So this guy is your absolute maximum point. Who is the smallest y coordinate? -13. So the point -1, -13 is the absolute minimum point. Does that make sense? All right. Let's do another one. You notice my function has to be continuous within my interval, and you notice I have this divide by x problem here. But 0 is my problem point, but 0 is not inside my interval, so I'm not worried about it. So first thing I'm going to do is get my critical point, but before I do that, I'm going to clean them up. F of x equals -3x minus 507x to the -1. So now, I'm going to take my derivative. Derivative of -3x is -3. What's the derivative of -507x to the -1? Well, -1 times -507 is plus 507x to the -2. I'm going to set it equal to 0 and solve. I'm going to clean this guy up. -3 plus 507, negative exponent goes on the bottom, over x squared equals 0. I'm going to add 3 to both sides. So I end up getting 507 divided by x squared equals 3. Now, again, I'm solving, so I'm trying not to skip any steps on the algebra here. I'm going to multiply both sides by x squared. And that's going to give me 507 is equal to 3x squared. Then I'm going to divide by 3, and that gives me x squared is equal to, time for a calculator because I don't know that one, 507 divided by 3 is 169. Does that make sense? But now, what do I got to do to solve for x? I got to take the square root. And when I take a square root, I got to take plus or minus, right? So I get two answers. X is equal to negative, the square root of 169 is 13 actually. Negative 13 and x equals positive 13. But don't forget to compare it to your interval. What's my interval? Between 6 and 14. This number, 13, is inside this interval. That's a good point. This one is not. So I'm going to omit him. I don't need the negative 13. He's not inside my interval. You only use the critical points that are inside your intervals. And now, let's go and find the actual max min. My critical point is at 13. My end points, I have 2. It is at 6 and at 14. And I'm going to plug all three of these x coordinates into my original function. So negative 3 times 13 minus 507 divided by 13, plugging in x for 13, and I end up getting negative 78. Now I'm going to plug in 6 into this function. And I end up getting negative 102.5. And now I'm going to plug in positive 14 into this function. Negative 3 times 14 minus 507 divided by 14. I end up getting negative 78.21428, whatever. Which one happens to have the largest y coordinate? Now, I know they're all negative, so the smallest negative would be the biggest one. So which one is that? The one at 13, negative 78. Negative 78 is bigger than the negative 78 point, whatever. So this is going to be your absolute maximum point. which one has the smallest? The larger the negative, the smaller it is. Which one has the smallest? The negative 102.5, so the 0.6 comma negative 102.5 is the absolute minimum. Does that make sense? All right, take a look at the next guy. F of x equals 6x cubed minus 99x squared plus 540x. First thing I'm going to do, over the interval between negative 4 and 8. First thing I'm going to do is take my derivative. Derivative of 6x cubed is 18x squared minus derivative of 99x squared, well, 2 times 99 is 198 minus 198x plus 540. Derivative of 540x is 540. I have an 18 in common in all these guys, so I'm going to take my derivative. I'm going to factor out the 18. That gives me x squared minus 198 divided by 18 is 11. X plus 540 divided by 18 is 30. Equal to 0. Now I'm going to factor it. What times what is 30? That adds up to be 11. 6 and 5. Very good. And because it's plus, they're the same sign. Because the middle terms are negative, they're both going to be negative. So I set each factor equal to 0 and solve. Add 6, you get x equals 6. Add 5, you get x equals 5. And notice both 6 and 5 are inside my interval between negative 4 and 8. So at this time, I've got 2 critical points. My critical points are 5 and 6 compared to my endpoints of negative 4 and 8. So I'm going to plug all these guys into my function here. 6 times 5 cubed minus 99, oops, there's an error there, John. Cubed minus 99 times 5 squared plus 540 times 5. I end up getting 975. Plugging in 6, so once you get it in there, it's easy to edit this thing. Plugging in 6, I get 972. Plugging in, I'm going to plug in 8 first because it'll just be easier to do. Plugging in 8, I get 1056. And plugging in negative 4, I have to insert negative 4 and delete the 8. Insert negative 4 and delete the 8. And one more time, insert the negative 4 and delete the 8. And I end up getting negative 4,128. So now look and compare these y coordinates. Which one has the biggest y coordinate? 1056. This is the absolute maximum. Which one has the smallest y coordinate? Negative 4,188. This would be the absolute minimum. And notice this time they didn't happen at the critical points. They happened, both of them happened at the endpoints. It does happen. Does that make sense? Well, let me do this one down here because it's a word problem. If I got time, I'll do this one, but I want to make sure I do this one because it's a word problem. All right, here it is. Word problems typically a little bit easier because you don't have to find the absolute max and min. Usually once you just find one of them. Here it is. The cost of producing X electronic games is given by C of X equals 1,080 plus 42X plus 0.3X squared dollars. Find the value that minimizes the, average cost function. What was our average cost function? C bar of X, which is C of X divided by X, which is equal to 1,080 plus 42X plus 0.3X squared divided by X. And I'm going to show you guys a little trick to save some time. Clean it up. Since you're dividing it by a single term, you can put that term under each term here. That's 1,080 divided by X plus 42X over X plus 0.3X squared over X. And it cleans up nicely. So C bar of X would be equal to, I'm going to clean this up. This will be 1,080X to the negative 1. Just brought them to the top. Here the X's cancel. It's plus 42. Here one of the x's cancel, I'm left with plus 0.3x. I just cleaned up my average cost function. John's fun rule calculus, to better clean up your algebra before you calculus and afterwards. Now, the next thing I'm going to do is, I want to find the critical values. To find the critical values, I'm going to take my derivative. The derivative of 1080x to negative 1 would be negative 1080x to the negative 2. Derivative of 42 is 0, and the derivative of 0.3x is plus 0.3. I'm going to set it equal to 0, and I'm going to solve. So this would give me negative 1080 divided by x squared plus 0.3 equals 0. I'm going to move this negative term to the other side. This would give me 0.3 is equal to positive 1080 over x squared. Again, try not to skip any steps here. I'm going to multiply both sides by x squared. Get rid of my fraction. That cancels. I'm left with 0.3x squared is equal to 1080. And then I'm going to divide by 0.3 on both sides. And I end up getting x squared is equal to, time for a handy dandy calculator again. 1080 divided by 0.3 is 3600. And now what am I going to do? Take the square root of both sides officially plus or minus, so x is equal to negative. The square root of 3600 is 60, and I get x equals positive 60. But look at your interval. Between 0 and 90, I don't care about the negative 60. Does that make sense? So now I've got the critical point, which will be the point 60, and then I can compare it to my endpoints. My endpoints are 0 to 90, 0 and 9. So I'm going to plug all these guys back into my, remember, the original function, which is my average cost equation. So here we go. This will be 1080 times 60 raised to the negative 1 plus 42 plus 0.3 times your x value, which is 60. I end up getting 78. Plugging in 0 into this thing, well, 0 does not exist because x to the 0, you can't divide by 0, so this would not be an actual value on this particular one here, okay? And then plugging in 90. Plugging in 90 on this guy. This is actually a typo, they should have said that, but that's their fault. All right, plugging in 90. I end up getting 81. And so what do they want me to actually do on this particular problem? Remember the question. All they care about was minimize. Which one had the smallest y coordinate? So this is your absolute minimum. Remember, answer the question. Find the value of x that minimizes. So what is my answer? X is equal to what? 60 units. 60 electron gains. The answer is 60. Does that make sense? Hopefully you got a homework set. It is due on Monday. Your test is on Wednesday. This is a great review of what I plan on making up for your test. See you guys then.